Variable ignition timing advance. Modern electronic fuel injection systems often control more than just fuel delivery. The spark events are also controlled by the ECM. Depending upon engine speed and engine load, the spark event may be required to occur much sooner or later in relation to the piston traveling toward top dead center. Variable spark advance is a tool used to always keep the engine producing maximum leverage on the connecting rod and crankshaft, thus making the most torque and efficiency possible. If we take a closer look at the process, fuel takes some time to burn inside the combustion chamber relative to engine speed. To accommodate this, the spark event needs to happen much earlier than the piston achieving top dead center. Here we can see the fuel-air charge being compressed during the compression stroke. Once the crankshaft reaches a predetermined angle, as pointed out to the ECM by the crankshaft position sensor, the ECM closes the ground to the ignition coil, completing a circuit. Up to 15,000 volts now travel at the speed of light to the spark plug and jump across the air gap to start the fire in the combustion chamber. Four-stroke engines require 2 full turns of the crankshaft or 720 degrees of rotation to complete 1 full cycle for an individual cylinder. If we look at the spark events during various operation modes, we can see the difference of when the spark occurs relative to engine rotation degrees. Let's look at some varying operating condition examples. When the engine is operating under moderate load and high-speed conditions, the proper spark advance will be delivered at 340 degrees, or 20 degrees before top dead center. When the engine is operating under light load and high-speed conditions, the proper spark advance will be delivered at 319 degrees, or 41 degrees before top dead center. When the engine is operating under heavy load and high-speed conditions, the proper spark advance will be delivered at 349 degrees, or 11 degrees before top dead center. Here are examples of how improper timing can affect the engine's performance. Let's say the engine is operating under moderate load and high-speed conditions, and the spark advance is delivered too early at 319 degrees or 41 degrees before top dead center. This can cause improper combustion events like detonation that affect power and performance and can even damage the engine. As a final example, say the engine is operating under moderate load and high-speed conditions and the spark advance is delivered too late at 355 degrees or 5 degrees before top dead center. This can cause poor engine power, excessive exhaust gas temperature, and a glowing exhaust system due to the wasted energy being placed into the exhaust instead of producing useful work. Once the mixture is ignited, it rapidly burns and expands. This expansion of gases is what is used to drive the piston down, thus turning the crankshaft. This process requires a careful balance, as there are many ambient variables that affect the optimal timing. This functionality is a major improvement over a fixed timing system, and is the other half of how EFI brings refinement, performance, and fuel economy improvement over their carbureted counterparts.